So the last thing we're going to talk about are accessor and mutator functions. So the number remaining function, that is an accessor function, and it lets you access information from the class. So basically, it's an approved way to get information from the class. So essentially, if something is private, you can create an accessor function so people can access it and see what it is, but not tamper with it, is kind of the idea. So like customers can see the price, but we don't want them to change the price. You can also have functions called mutators. You can modify the value of a private member of the variable. So maybe we wanted to give a worker the ability to reset the inventory value when they restock it. So basically you have to have somebody with a certain knowledge of how to get to the function, and it's just sort of like a layer of protection so that like only the person stocking the machine knows how to access the inventory function and change it basically. So a lot of the stuff in this code will be the same, so we don't necessarily have to discuss all of it because a lot of it is the same as before. But let's see what we have here. So I've moved all the variables back to private. So again, the inventory is private again. Let's see. So here we've got a restock function. And so this is the mutator function. So the function restock is a mutator function that lets us set the inventory level. In the main program, we can call the restock function and fill it to 200 items. So the restock function here, we're calling the restock function right here, lobby machine.restock. And so even though the inventory variable is private, we can call the restock function and set a new value to it. And then likewise, we have an accessor function for the number remaining. And that's going to let us see how many items are in stock. So we've got a number remaining function. The function, you'll notice, is public. And all it does is it just returns the inventory. But the inventory itself is private. So we can look at the inventory with this function, but we can't change the inventory because it is private. We have to use this function. We have to use a function to change the inventory. A lot of this stuff is all the same because, yeah, that's not any different. So in our main program, we're making the vending machine. We're going to restock it to 200. We're going to tell everybody how much there is, do the deposits of the money. And then here we're, if we vend successfully, we get an item. Otherwise, we don't get an item. And then we'll output the number of items that are left. Because remember that when we vended things, we did inventory minus. So after we do this, we should go from 200 items to 199 items. So here we go. We have 200 items in stock, 25, 50, 1.1. We vend an item, we get 10 cents change. We got an item, and there are 199 items left. Hooray. So let's see here. So why not make them public? The accessor mutator gives us control for how these variables are used. We limit the possible values of those. We can limit the possible values of those functions, and we can also change what users are allowed to see and do. We could, for instance, have a check in the restock function. Here we basically say, if the new number is positive, we're going to reset it. And this way, you basically can't have an inventory that's a negative number. Something else we could do, we could keep a log of which members are accessing the private information. If a public member is changed, there's little that we can do about it, especially if it's changed to an invalid value. Accessors and mutators allow us to ensure that the overall object maintains its consistency. So basically, it helps to make things, shall we say, foolproof. The dominant method of programming these days is object-oriented programming, OOP. It makes full use of C++ and its features. Classes, we can create new objects, and each class we make creates a new type. So that is what OOP is, and that is what classes are, which are really the backbone of what OOP is about. And that is all I got.